Hello, friends. Good morning. Good morning to all of you. Okay, in this lecture of photochemistry, we will go for Jablonski diagram. This Jablonski diagram explains different photophysical phenomena taking place in excited state. We know molecule absorbs a quantum of radiation, quantum of energy, and it get excited in higher energy state. Now what happens in higher energy state? Here we will see only physical phenomena taking place in excited state, photophysical phenomenon taking place in excited state, and those photophysical phenomenon taking place in excited state are explained with the help of this Jablonski diagram. This diagram explains all the photophysical phenomena taking place in excited state. Okay, before starting this Jablonski diagram, we must aware of some of the terms used in this Jablonski diagram. Now, if we consider any ground state molecule, this ground state molecule, all the electrons are paired. Spin of electron is paired. Now, if spin of electron is paired, then what is the total spin? Total spin S is equal to spin of one electron plus spin of other electron. What happens here? Spin of one electron is plus 1/2 and spin of other electron is minus 1/2. Total spin will be 0. Yes, this is called as a total electron spin. Total electron spin. Now this total electron spin is 0 here. Now if we determine its multiplicity, it is a quantity determined with the help of 2s plus 1. Here S is a total electron spin. Now if the electrons are paired, then what is the multiplicity? Multiplicity 2s plus 1 value will be 2 into 0 plus 1, means it will be 1. Multiplicity of that particular state is 1. It is called as a singlet state. It is called as a singlet state. Okay. If the electrons are parallel, it is not happening in ground state, but suppose the electrons are in parallel condition, then what happens? Total spin S is equal to S1 plus S2, that will be plus 1/2 equal to 1. And in that case, multiplicity is equal to 2s plus 1. It is equal to 3. It is called as a triplet state. It is called as a triplet state. Yes, denoted by T. Singlet state denoted by, yes, we will take bold S for singlet. Total spin is different and this singlet state is different. Why it is singlet state? Excuse me. the electrons are paired. Since in ground state all the electrons are paired, generally any molecule it is present in singlet state. Now what happens if there is an absorption of radiation? Suppose these are the two electronic energy levels. Initially the electrons are paired. Yes, since the electrons are paired, we can say it is a singlet state. It is a singlet state. Now it is a ground state, that's why we can say it is a singlet ground state. S0, it indicates that singlet ground state. Now when there is a absorption of radiation, electron get excited. Suppose these are two energy states. One electron is clockwise, other is anti-clockwise. It is also called as a singlet state. This is also a singlet state. But here, since the electron is excited, we can say it is a excited singlet state S1. If the electrons are parallel, this can be happen. Yes, two electrons in two electronic energy levels, this step is possible. Two electrons in two different electronic energy levels, and they can have a parallel spin. Now it is called as a triplet state. Say T1, triplet excited state. Okay, got it? What is meant by singlet? What is meant by triplet? Now when molecule absorbs energy, any ground state molecule absorbs energy, there is a excitation of molecule. And when excitation took place, generally most of times higher singlet states are populated. Means electron goes in the higher energy level, but there is no such change in its spin because this absorption is so fast. Transition of electron from lower energy level to higher energy level is so fast that there is no change in spin. That's why when there is an absorption of radiation, almost all times there is a no change in spin of electron. Okay, electron jumps from lower electronic energy level to higher electronic energy level. Now to understand this Jablonski diagram, now what is the Jablonski diagram? What happens on absorption and emission? Wet, okay, this is the Jablonski diagram. See, this is S0. What S0 indicates? What S0 indicates? It is the singlet ground state. Yes, this is the singlet ground state where electrons are paired. Okay, now when it absorbs radiation, the transition takes place from ground state to higher state. These are the electronic energy levels. We know the electronic energy levels in spectroscopy also we studied it. Yes, lower electronic energy level, higher electronic energy level, higher electronic energy level. Now, it is called as S0 because this is not about electronic energy level, ground electronic energy level, but it is called as S0 because electrons are parallel and in ground state. When radiations are bombarded on that particular sample, electron get excited. Now, depending on the energy of photon, the transition may took place from S0 to S1 or from S0 to S2. Now, what are these lines? What are these lines? These lines are vibrational energy levels. We know each electronic energy level consists of large number of vibrational energy levels. Yes? Initially, suppose all the molecules are present in lower electronic energy level, ground electronic energy level, say S0. We are saying it S0 because it is a singlet state. Electrons are paired. Now, when it absorbs radiation, it undergoes excitation from S0 to S1, higher electronic energy level. S0 to S2, higher electronic energy level. In higher vibrational level also. Here also there is a excitation from S0 to S2. Here S0 to S2, singlet high energy state with higher vibrational level. Say here V0, V1, V2, V3 and so on. Here also V is equal to 0, 1, 2, 3 and so on. Yes, when molecule absorbs radiation, a quantum of radiation, it undergoes excitation from S0 to S1 in higher vibrational level also. Here also in higher vibrational level. There may be transition from this to this also, here also. But higher vibrational energy levels are again unstable state. It undergoes vibrational relaxation. If we consider here, this is the vibrational relaxation. It is a non-radiative transition. Vibrational relaxation. We can say VR. What is vibrational relaxation? In higher electronic energy level, if molecule is present in higher vibrational level, it comes to ground vibrational level of higher electronic state. This is the excited electronic state. In excited electronic state, when molecule is present in higher vibrational level, it comes to ground state by vibrational relaxation. It is vibrating with higher energy. It comes to lower energy in excited state, excited electronic state. Okay, it is called as a vibrational relaxation. It is a non-radiative transition. Vibrational relaxation. It takes time in the range of 10 raised to minus 12 to minus 10 seconds. Here also there is no change in spin. Absorption, see this. There is a one rule called Frank-Condon principle. During excitation of molecule due to absorption of radiation, radiations are so fast, it requires 10 raised to minus 15 seconds. Radiations are so fast that there is no change in spin. Okay. Now, due to vibrational relaxation, it comes to ground state. See here, the ground vibrational state of S2 is equivalent in energy of the higher vibrational level of S1. There is a transfer from S2 to S1 from higher electronic level to lower electronic level. Excited state means such transformations, such transfer from S2 to S1. It is called as a internal conversion. Denoted by IC. Internal conversion, what you understand with this internal conversion? Internal conversion is the transition from one higher singlet state to lower singlet state. Yes, this is the internal conversion from higher singlet state to lower singlet state. Again, there is a vibrational relaxation. Comes to ground vibrational level of excited electronic state. Okay. Now, since this is a higher energy level, there is a again transition from higher singlet state to lower singlet state. This transition is called as a fluorescence. It is a fluorescence. It is called as a fluorescence. Means S2 to S1. It is called as a fluorescence. Higher singlet state. There may be fluorescence from S2 to S0 also. This can be called as a fluorescence. Higher singlet state to ground singlet state means S1 to S0, S2 to S0. It is a radiative transitions. Radiations emitted during this transformation is called as a fluorescence. Yes, what is meant by fluorescence? There is a emission of radiation when a molecule comes to ground singlet state from excited singlet state. Ground singlet state from excited singlet state. This transition is called as these transitions are radiative transitions called as a fluorescence. And transition from higher excited singlet state to lower excited singlet state. It is called as an internal conversion with the help of vibrational relaxation. There is an intermediate vibrational relaxation. Yes, this vibrational relaxation. Vibrational relaxation, this is the internal conversion. It is again vibrational relaxation. Here may takes place internal conversion. Again vibrational relaxation comes to ground state. This can be happen. Means continuous vibrational relaxation, internal conversion, vibrational relaxation, internal conversion, vibrational relaxation. Molecule may come to ground state without emission of radiation. This may happen. There may be no emission of radiation and molecule come to its ground state. Yes? Okay. And what is fluorescence? Fluorescence emission, it is the transition from higher singlet state to ground singlet state with emission of radiations. Generally, this fluorescence emission have a low wavelength. Not low wavelength, higher wavelength. Sorry. Generally, this fluorescence emission have a high wavelength. Means low energy. Why fluorescence has a lower energy than excitation energy? Why fluorescence has a lower energy than excitation energy? See here. If the molecule is going from singlet ground state, see this singlet ground state to excited singlet state, suppose S1, S0 to S1, this transition called as a S0 to S1, this transition called as a absorption. Now during this absorption, depending on the energy of photon, the transition may be in the higher vibrational level. And due to vibrational relaxation, some energy is lost. That's why the fluorescence emission have a lower energy. Fluorescence emission have a lower energy than absorption energy. Okay. Now here what happens again, one more conversion. When molecule is present in higher singlet state, okay, from higher singlet state, there may be transfer of that electron from singlet to triplet state, this transfer. From higher singlet state to higher triplet state, high energy singlet state to high energy triplet state. Now what is that triplet state? The transformation from singlet S1 to T1. Why there is a transformation from S1 to T1? Here in case of S1, what is there? Electrons are having paired spin. And there is a conversion of that spin. Spin is changed in higher state, and this requires quite large time. This requires quite large time in the range of 10 raised to minus 3 seconds. Yes, this conversion is called as a inter-system crossing, ISC. What is inter-system crossing? Yes, what is inter-system crossing? It is the transfer of a particular molecule from excited singlet state to excited triplet state, maybe S2 to S3, not S3, maybe S2 to T2. And this requires quite time, more time. Okay, now here see Jablonski diagram. This is called as an inter-system crossing, ISC. Maybe in higher vibrational level also, there is again vibrational relaxation comes to ground state. And mind well, singlet states have a higher energy than triplet state. And it comes to ground state. Higher, not ground state, lower state. Now from triplet to singlet transition. This higher triplet state to ground singlet state. What it require? Again, there is a triplet to singlet transition. Triplet means the electrons are parallel, spins are parallel, and in singlet state here the electron spins are paired. Here the electron spins are parallel, due to which it is called as a triplet state. Yes. Now here again for this transformation from triplet to singlet, there should be a change in spin of electron. Again it requires time. And this emission is a radiative transition from higher triplet to ground singlet. See, from higher triplet T1 to S0, it is called as a phosphorescence. It is called as a phosphorescence. Yes, it is called as a phosphorescence because it requires time. Now, what is difference? Main difference between fluorescence and phosphorescence. Fluorescence emission means from S1 to S0 or S2 to S0. This emission stops as soon as source of excitation is stopped. As soon as source of excitation is stopped. Means if we consider this, suppose this is a fluorescent substance, fluorescence emitting substance. If we bombard radiation, there is a emission of light. There is a emission of light from this substance. Yes, these emitted light have a low energy, lower frequency, lower energy, higher wavelength region. But as soon as excitation source is cut off, the fluorescent emission also stops because they are very fast processes. But if we consider phosphorescence, this phosphorescence phenomenon continues. This is the main difference, and how you can identify whether it is a fluorescence or phosphorescence. As soon as source is stopped, fluorescence stops. But phosphorescence emission continues. Means we can identify whether this substance is showing fluorescence or whether it is showing phosphorescence. Phosphorescence emission continues from as we cut the source of excitation. If we stop the source of excitation, phosphorescence continues, fluorescence stops. Yes, got it? What is fluorescence and phosphorescence? Means, see here, S2 to S1 transition through vibrational relaxation. It is called as an internal conversion. Yes, transition from S2 to S0, S1 to S0. This is the radiative transition called as a fluorescence. S1 to T1. This is also non-radiative transition. Higher singlet state to higher triplet state. Yes, it is called as a inter-system crossing. It is called as a inter-system crossing. Here, transition from higher triplet state to ground singlet state. There is no ground triplet state. Yes, in ground state, electrons are always paired. That's why there is no ground triplet state. Higher energy triplet state to ground singlet state, it is called as a phosphorescence. These types of transitions are taking place. Again, there are other transitions also. Delayed fluorescence, E-type delayed fluorescence, P-type delayed fluorescence. But as a primary, we must know what is internal conversion, what is fluorescence, what is inter-system crossing, and what is phosphorescence. In simple diagram also you can explain like this: ground singlet state S0, higher singlet state S1, S2, S2, S3, and so on, higher energy, and triplet state, say T1, say T2, say T3. This transition from S3, suppose S2 and S1. this transition from, not radiative transition, this transition what is called internal conversion, higher singlet to lower singlet through vibrational relaxation, higher singlet to lower singlet, it is called as the internal conversion. Higher singlet to higher triplet, this transition called this transition is called intersystem crossing, higher singlet to higher triplet. Why it is called as intersystem crossing? Because there is a change in spin. Okay, it is a triplet state, and from triplet to singlet it requires again time. It is called as a phosphorescence. And from singlet to higher singlet to ground singlet, it is called as a fluorescence. Got it? Okay. Okay, thank you. In next lecture also we will just revise these and go for next one. Thank you.